Okay, it tells you that if you form a square on its hypotenuse, the area of this square is equal to the sum of the squares of the other two sides. So this has been proven to you when you were in lower sec. If you go and form 3 squares using the 3 sides of a right angle triangle, the biggest one, the area of the biggest square will be equal to the sum of the other 2 squares. So this has been established for you by Pythagoras theorem, so nothing new, we will use that. And then they tell you that the ratio of the 3 different sides, you could actually do a OA, AH, OH. But if you go and jumble them up, right? In A math, we will always do this kind of thing, right? So this is OA. What about AO? Right? So you will learn in A math that is called cotangent. Okay, because it's 1 out of tangent. So if you reciprocate your tangent, you'll become cotangent. That is reversing the ratio, that's all. Okay, same thing here. What about you reversing the ratio here to be H over A? You flip it, right? You're going to flip this ratio reverse. Then this will introduce secant. Okay? And then if you reverse the ratio OH to be HO, then it becomes cosecant. So in A math, when we go into trigo, you will see cotangent, secant, cosecant. But it is just the same as 1 over tangent, 1 over cosine, and 1 over sine. It is just another ratio they came up with, and then they came up with another function to represent it. Okay, but E math only tua kaso. You won't see cosecant, cotangent, and secant. Okay, you will only see tua kaso. So that's the only thing. Yes. Inverse we will learn principal value, but that is also at a later time. Which one inverse? No, this one called reciprocal. Inverse is like that. When you solve the angle, remember? Do you all remember when you all need to solve the angle, you need to inverse your tangent? This one called inverse. This one called reciprocal, different. Yes. No, inverse means I bring the tangent to the other side. But reciprocal is I divide it.
Because you're putting tangent to the arm.
This one? Yeah, that's why we call it inverse lah. But you're saying this one is it. But this one is a different thing already. Okay, but don't worry too much. We'll explore this very in-depth when we go trigo A math. And there's a whole lump of trigo chapters that will welcome you with love. End of the year and the start of the whole year, next year. Okay, so anyway, this right, I don't think I need to go through. Do I need to? You all can go back do as homework, Picasso, or cannot? Okay, you do now. Run through. As in go through a few, huh? Okay, PQ, this one easy, right? PQ, what do you do? How to find PQ? Yes, Pythagoras theorem. What should I do? Yes, so PQ is 10 square minus 6 square, and then you take a square root. So it is 8. Okay? So this is Pythagoras theorem by PT. Okay. No lah, you spell Pythagoras theorem. You all work harder. I've worked hard already. Okay, next one is if they ask for the fraction in its lowest term. So I want to find tangent of this angle. Instead of using theta, they use x, so no problem. How come become star? Nowadays, they keep detecting weird shapes. Okay, whatever. Okay, so anyway, this is the angle that they are talking about. So how do we identify hypotenuse, adjacent, and opposite? Where is hypotenuse? PR, this one. Hypotenuse is always the longest side opposite the 90 degree. Where is the adjacent side? PQ, this one. Because it's just next to your angle. Okay, and then of course this is opposite. So once you identify your how, right, HAO, then you can start doing your trigo ratio. So tangent of the angle X is O over A. So O is 6. Oops. Okay, O is 6. And A is 8. So give me your fraction in its lowest term. So answer is just 3/4. Okay, don't go and find the angle. So don't tangent inverse and find angle. I just want the ratio. If you want to find the angle X, you will do tangent inverse 3/4. So how to call out the function tangent inverse? You shift tangent, then you key in 3/4. They will give you the answer of the angle. Okay, but I don't want the angle yet. Okay, for now, it's just the ratio. Okay, same for cosine. Cosine X is what over what? Remember your toi, your ka, your so. Adjacent over hypotenuse. So it's A over H. So it's 4/5. Then lastly, they say using your sine X. So using your sine X. So sine ratio is what over what? Okay, so opposite over hypotenuse. So it's 6 out of 10, which is 3/5. They say then you go and find the angle X. So if you want to find angle X, you need to sine inverse your 3/5. So go and press that using your calculator. What is the angle that you get? Leave to 1 dp. Angle is always 1 dp. Yeah, 36.9. Okay, 1 dp. So angles answer accuracy to 1 dp. Okay, if those of you who get a different answer using your calculator, it must be that at the top panel of your calculator is not in the degree mode. It could be in the radian mode, which you need to change to degree mode. At the top panel of your calculator, you should see a D there. If you don't see a D, then something is wrong. You have to shift setup, go to the angle unit and change to degree. So if not, shift setup. Our gradient is in tertiary, so we don't use that in secondary school at all. Shift setup, then choose your angle unit. Make sure it is in degree mode. Okay, you will use radian when we go into arc length sector area in chapter 9. But now we don't need. Okay? So that is Tuakaso for you. And then same thing here. If I want to find X, I zoom into this triangle. First step is always to identify your how. Your H, A, and O. So where is your H in the red triangle? The 28. Always the longest length opposite the 90 degree. Then for your angle here, aiyo. Okay, don't know what happened. Okay, your angle that is here, then your adjacent side will be here, and then your opposite will be your X. So always identify your how properly first. So in order to solve for X, I want to find O, I have H. Which ratio should I use? Sine, because it's so. So sine of the angle, sine is always attached to the angle one, is equal to the ratio O over H. Then the rest is algebra solving. Okay, cross multiply. Okay, 18.0. Length is 3SF. Okay, next triangle to focus on, the green one. So remember, no matter what, when you have a right angle triangle, go and identify the how first. So H is opposite the 90 degree. Since your angle is here, so adjacent side is next to it. And then this part here is your opposite. So you ask yourself, you want to find the unknown angle, you need both ratio of the sides to be known to you. So I have O, I have A. Which ratio should I use? Which one? Tangent, because it's 2. So tangent of the angle Y is equal to opposite over adjacent. So in order to find the unknown angle Y, you need to do a tangent inverse. So when you are finding angle, that's where you take inverse. Okay, when you are finding angle. Okay, you will get 61.8 degree, 1 dp. Okay, last 3 question homework, Ken. It's your Sec 2 work. Okay, this one, the part A is your converse of Pythagoras theorem. So can you do on foolscap paper so that I can see your presentation, see whether there's anything that I need to refine. So question 3, 4, 5, do on foolscap paper. Okay, but if you have already done on your notes, it means you need to tear out for me. But if you do on foolscap paper, I can collect. Okay, so 3, 4, 5, do as homework. I just want to highlight isosceles triangle. Can I? 机会 later I put the notes in my locker when take. Okay. Done? Okay, next one. Isosceles, very important. When they tell you you have an isosceles triangle, the perpendicular line is a very magical thing. If you have an isosceles triangle and you drop a perpendicular line to the base, it will cut the 2 triangles into congruent ones. This one is an automatic fact of isosceles triangle that they don't tell you. It's a hidden property. So if you drop a perpendicular line, straight away, these 2 are right angle triangles. Okay, straight away, these 2 are the same. Okay, and this will be equivalent. You will cut these 2 angles into exact halves. So this is a property of isosceles triangle that you need to know. So it says state the name of the given to the triangle shown above. What is it? What kind of triangle? Yes, isosceles triangle. Isosceles is C-E-L-E-S, not C-I-L-I-S. I have students who spell it wrongly. Okay, size of the angle Y. Okay, my angle Y is up above. It is a combination of 2 small parts. So if I can find half of it, I can find the full Y. So I'm just going to zoom into this right angle triangle. Oh, actually, I just straight away find angle will do, right? Oh, I don't even need this. Okay, good. So I'll just 180, take away 40, take away 40, and that's my Y. 100. So this is base angle of isosceles triangle. But if they never ask reason, you never write, it is fine. I'm just putting it here as a recap.
That's because it's not drawn to scale.
Okay, next one. If we zoom into this triangle 5, 40, and question wants me to find this full length. So that means I need to find half of it first. Okay, let me call this M so that it's easier to find. So if you have a right angle triangle, first thing you do is identify your H, your adjacent side, and your opposite. So I want to find A. This is what I need to find, and I have H. So what should I use? Cosine. So cosine goes with the angle 40 and is equals to BM over 5. So cross multiply. BM is 5 cos 40. Okay, don't need to evaluate using the calculator first because this is not your final answer. Let's keep it as exact as we want. Okay, so now to find BC, I multiply this by 2. So you will get an exact answer that you don't have to lose accuracy marks. So 7.66 cm. Length 3SF. The X is? The X is at the bottom. What do you mean? Oh, we will still cross multiply. That means instead of this on top is at the bottom. You cross. Recently it's crazy. I don't know why it keeps detecting weird stuff.
You cannot press and hold.
Okay, I cannot press and hold. Nonsense. Okay. Okay. Those of you who are asking, what this is the case where we bring up, we should already get the answer, right? But what if the expression is this?
Then don't we just divide that?
You can swap the position of these two, and then to find BM is 5 out of cos 40. So if the expression is this way, then the BM goes up, cos 40, you bring it down to
So
B5.
you just divide cos 3 when you divide
By the 5, yes. 5 divided by cos 40. Okay, so this is if the ratio is inverted. Okay, not in such a neat way. Okay, but this one you can ignore for here. Okay, last one, I want the perpendicular distance, this one. How to find that? That means I want to find O now. I have H. What should I use? What should I use? Sine. So sine of the angle 40 is AM over 5. So AM is 5 sine 40. So find sine 40, which is 3.21 cm. Okay, just now I heard some of you saying I can use Pythagoras theorem. Can. But if you use Pythagoras theorem, please be as exact as you can. That means when I zoom into this triangle, this was 5. Don't use the rounded off figure. Use 5 cosine 40. Okay? So when you 5 square minus 5 cosine 40 square, and then you take a square root, it will also give you the answer 3.21. But if you use a rounded off figure 7.66 and then you go and square it, you go and subtract, you square root again, your final answer will be off 3.21. Then you will lose accuracy mark. So if you want to use Pythagoras theorem, please make use of this original exact number. Then you can get the answer. Okay? So this is isosceles property that is good for you to note. Yeah lah. Can you also do the next few examples as homework or classwork now? So example 2, just do on the notes. Okay, we rested enough. So this is one of the sides of the triangle. So first question, to find BC, I will use Pythagoras theorem. So hypotenuse square minus 1 of the square of one of the sides. and then you take a square root. Okay, so if you press calculator, what is the value that you will get? 12.173. So always give 5 sig fig first, and then you give me the actual 3SF. Yes. E. This is E. Okay, so once you are done with finding BC, next I'm interested in finding the angle ABC. This one. So same thing, I have a right angle triangle. In order to find angle, I need to use Tuakaso. So this is my hypotenuse, adjacent side, and opposite. So if I look carefully, I have O, I have H. Although I've just found A, in case I've made a mistake with A, it's safer to use the two given ones than the A that you just found. So between O and H, what ratio should I use? Tuaka also. O and H. All three can, but OH we use what? Sine, So sine of the angle ABC, it's O over H. So to find the angle ABC, bring the sine over to get sine inverse. Ravan, you ready or not? Ravan, yeah, correct. Ravan. Okay, so what is the answer for the angle? 28.1. Okay, 1 dp. Okay, but good practice to give me 5 SF. What is it?
28.100.
Real, Yeah. Okay. Because you look like you're joking. Okay, so that is the B. So every time it's a good practice to go and put in the value just found. So this is the 173. Okay, last one. I want to find the length of DC only. This part. So that means I don't want to look at the big triangle already. I'm just going to focus on the smaller one. So if I focus on the small right angle triangle, the last one would be, this is hypotenuse, this is my adjacent side, and this is my opposite. So between HA and O, I have O and I want to find A. So OA means I use Teng. Okay, Tuakaso, right? So the toe that he was saying. So tangent 43 degree is O over A. So remember yesterday we were telling you if this appears at the bottom, you can switch the position of the two of them. So DC is 6.5 divided by tangent 43 degree. So press calculator, what's the answer? 6.97 cm, 3SF. Okay? So refer to the correct triangle, use the correct ratio to help you. So this one is the basics, the fundamental unit, where we go into 7.2 and 7.3 and 4. Yes. Chapter 7 is all the formulas. Chapter 8, we go into 3D shapes. But it's using what you have learned in chapter 7 to solve. Okay, so chapter 8 is 3D as well as bearings. Okay, bearings, going for the direction. Okay, let's go to the next example. Raj, you... Okay, or the soft copy is in the Google Classroom also. How like that? How like that? Okay, next one. 3, 4. This one no need to do on the foolscap paper. You can. Example 3. I want to find AB. So if you want to find AB, we can look at the small right angle triangle here. So to find AB, I need to label my how. So H, A, and O. So if I want to find A and I have H, then I will use cosine. Yes, correct. So cosine of the angle 52 degree is AB over 3. So you do a cross. Cosine 52 AB over 3. So AB is 3 cosine 52. What's the value? 1.8. For one more? 469. So 1.85 meters. 3SF. Okay, but when you copy onto the diagram, use the more exact one. So you can change it to 3 cosine 52 degree. Part 1. Okay, next is part 2. I want to find the angle AEC. This one. So when I zoom into the triangle, I zoom into the triangle that has that angle. So it will be this right angle triangle that I'm looking at. So again, identify your how. It will always be the hypotenuse first, which is this one. Okay, the adjacent side. And then finally your opposite. So I have A, I have O. I want to find the angle. Which ratio should I use? Huh? Which ratio? O and A. Toa, to or toa. So tangent of the angle AEC is opposite over adjacent. So in order to find the angle, you do a tangent inverse. Okay? So answer? 198. So 1 dp 68.2. So if you want, you can label it. Okay, last one is the length of DC. So I want to find the length of DC. By right, I should focus on the tiny triangle at the bottom. But in order to find the tiny triangle, I need a little bit more info. So you see, D, C, and E. This is what I want to find. I only know this and I have no angles at all. So I don't have enough info. I must use whatever I'm given to help me find the next unknown. So you take a good look. Is there a way that I can find this angle? Is there a way that I can find this angle?
Yes.
How?
Adjacent and hypotenuse.
Adjacent and hypotenuse. Okay, you are saying about this one, right? H, A, O. Using A and H. But I don't have the length of A. That's what I want to find. But in order to use this pair, I need to have the angle there. So how can I find that angle? 180 minus the 90 minus this one, right? This one I can find. This one is like 38 degree. Okay, which is 180 minus 90 minus 52. So that is 38. So I need to first find ECD, which is 180. Take away the 90 degree. Take away the 38. So that's also a 52, right? Okay, so with this being 52, then now I can use my cosine. So cosine of the angle 52 is A over H. So CD or DC is just 1.2 cosine 52. What's the answer?
0.738.
So small. Okay, 3SF.
And then GSL is 0.739.
Oh, there's one more. Okay. So quite direct scales. Actually, all of this you have learned in Sec 2 already. Okay, it's all the same thing that you have learned in Sec 2. That's why it's called a 7.1 recap. The recap that you have done. The only new thing is if we move into the second quadrant, the obtuse angle. Okay, last example. Parallelogram. A is perpendicular and it meets CD at the produce at point E. So CD produce just means I extend the line CD and they meet at E. So that's what the question is telling you. AE is 8, AD is 10, CD is 10. No, CD is 10 and but here right 12 leh. So which one should we follow? They all use the 12 or the 10? You all use the 12, right? I'm sure you never read the question. Okay, so we change this to 12 then. Okay, then find ED. So they want you to find this. So one look at it, you know, zoom into the right angle triangle, use Pythagoras theorem. So part A, no problem, by Pythagoras theorem, ED or DE is 10 square minus 8 square square root. So it's 6, is it? Good to write by PT lah, minimally. Last time you all spell the whole thing out, right? So 100 minus 64, so 36, 6 lah. Okay? So that's this. So once you know the value, quickly go and write it there so that you won't miss out on the info. Next, you want to find the angle ADE. This one. So to find angle, you can always use Tuakaso to help you. So use the length they give you rather than the one you find. Okay, in case you make a mistake in your calculation. So this is your H, A, and O. We will use O and H. So sine of the angle ADE is O over H. So ADE is sine inverse. What's the angle? 130. So let's call it 53.1. 1 dp. Okay, next they want the angle DAB. This one. So you ask yourself, I have a parallelogram. Parallelogram has parallel sides. So this pair of sides are also parallel. So just now they tell you that actually this line is an extension. So if it's an extension, it's that same line. So can you see alternate angles? So actually, you can straight away tell me that part 3 is also 53.1 degree. Alternate angles, AB parallel to EC. That's it. Okay, so they are the same angle. Okay, then area of trapezium, the whole thing. Can you all still remember area of trapezium formula? Half times sum of parallel lines times the height. So, first thing first, this length is the same as this. They are both 12. Opposite sides of parallelogram, same length. So, 12 plus the bottom base, which is 6 plus 12, so 18. Okay, times the perpendicular height between the two parallel lines, which is 8. So don't choose the wrong one. In Sec 2, some of you may choose the 10. So that is not the parallel side. Must be the one perpendicular to the two parallel sides. So final answer? 120 cm square. So that's the trapezium. Yes. Sum of parallel lines. Okay, so remember this is your trapezium, this is your A, this is your B, this is your perpendicular height. Yes. Go. The counselors go. Okay, so you sum up the two parallel sides and then multiply by the height. They want trapezium. Okay, do you all remember parallelograms formula? How to find area of parallelogram? Same as square, or rather rectangle. Base times perpendicular height, right? So to find the area of this parallelogram, I will use base times the perpendicular height 8. So in this case is 96. Okay, so I have the area of this parallelogram. Why do I need that? Is because it will help me find the shortest distance or the perpendicular distance. So they say I want to find the perpendicular from B to AD. So supposedly here.
Divide the parallelogram.
No need. Actually, this is the same parallelogram that we are looking at. If this is taken to be the base and this is taken to be the perpendicular height, then they should give me the same area. So now the base here is 10. So it is equivalent to 10 times the height that I'm trying to find. So actually H is just 9.6. Okay? So whenever they say perpendicular distance or shortest distance, think about area. Area is a good way to find shortest distance or perpendicular distance. So this is the trend they like to test. Okay? So that is it for, remember, we assuming that this is a unit circle. Unit circle meaning the radius of the circle is 1 unit. That means assuming that this is always 1 lah. Okay, this is always 1 by right. Okay, but in this case they let it be R, the radius. Okay, but later on the simulation that I'm showing you, I'm taking it to be 1 so that you can see it easily. Okay, if I have a point on a circle, I will have the X and Y coordinate. So remember, Tuakaso only works with right angle triangle. So we always draw a right angle triangle from the whatever point that we choose on the circle. So this is the right angle triangle. And this is the angle that is formed. So based on this angle form, this is my hypotenuse, this is my adjacent, and this is my opposite. It is always at the same place. Okay, and then this being my O over A, can you see why they use this to be Y? This length here is Y, right? Your Y value. And this X value here, your A is your X. And then they let this be the radius of the circle, but actually it's just 1. Okay, so O over A is Y over X. That's why they write Y over X. Okay, and then cosine is A over H, so it's X over R. That's why they put X over R. And then lastly, it's your sine, which is O over H. Then it's Y over R. So these ratios that they write here is nothing new to you. Just that when we put it on the grid, right? On the unit circle, they use it as this kind of ratio. Yes. R is the radius of the circle. But actually we can take it to be 1. Okay, so this is, imagine this dot, it can be from anywhere in the circle. And so far we have learned acute. Acute means it stays within the first quadrant here. Here. Within the first quadrant. That means my dot can start from 0, go all the way to 90. Okay, and then I can find all the ratio to be O over A over H, O over H. But what if this dot goes beyond the 90 degree into the second quadrant? Okay, for E math, we are only learning about 2 quadrants. But for A math, we go all 4. That means we go through all one circle, and not enough, we go in revolution. That means we keep going round and round. Yes, okay. So with that being said, goes to this part. What changes is that there are some values that becomes negative. Can you see closely? Okay, we do the same thing. Instead of X, what is this value now? Negative X. But this is still Y, right? No change. Still on the positive side. This one still no change because this is forever radius. It's always positive. So if I look at the angle, if my angle becomes obtuse, become more than 90 degree, what happens to my H, A, O? So we apply the same rule. So my HAO in this case will become what? What is my tangent now? O over A. So my O, no problem, is still Y, but my A is negative X. So can you see that my ratio become negative for tangent already in the second quadrant? Okay, and then cosine is A over H. So my ratio becomes minus X over R. So again, the ratio is negative now. Then my very last one is sine, which is O over H. Can you see that the ratio is Y over R? So it's positive. So I want you to make a good correlation between the acute ones and the obtuse ones. Is there a difference in the ratio that you found?
Yes.
What?
Tan and cosine.
Tan and cosine is negative. So can you see every value is exactly the same. No change in the value, but the sign is different for cosine and tangent. But okay, let me just show this one so that you can see that it's a bit different. And then for sine, it is both positive. There's no change. Yes. Acute angles better. There's no better angles lah. But just telling you that when we are stuck within the first quadrant, your cosine, sine, and tangent ratio is always positive. All three are always positive. But once we go into the next quadrant at the obtuse part, the sine still stays positive because my y value and my r value is the same. They are positive. Okay, but my x value becomes negative. So those ratio with my adjacent side will be affected by becoming negative. So can you see that? Okay, but another thing I want to point to your attention is this one. Why did they use 180 minus theta? Why did they use 180 minus theta? This one I use theta, no problem. Why this side I use 180 minus theta? Why? This theta is obtuse, right? When the theta is obtuse, that means more than 90 degree, you look. It's bigger than 90 degree, right? But when we are referring to the right angle triangle. So what is the angle in the right angle triangle that we are using? To represent this, can you see that this angle here is 180 minus theta? Instead of writing it as theta, we'll write it as 180 minus theta. We always put in a smaller value. But with that being said, don't need to be confused about it. When you see obtuse, which are the two ratios that will become negative? Tangent and cosine. So sine will stay positive. Okay, I just want this. I ask you all to compare these two. Obtuse and acute, how is it related? How is this cosine related to the acute one? Yes, so the ratio is the same, but just add a negative sign in front only. Okay, so they tell you that sine of P is 3, 5. Okay, this is the angle outside. But just now we learned that sine of P actually is the same as sine of 180 minus P. This one we learned already just now. The ratio is the same. They are both 3 out of 5. So this is O over H. So we ask ourselves, this one is H, A, O. So O is 3, H is 5, A is 2, 4. Because you use Pythagoras theorem, right? 5 square minus 3 square square root, you will get 4. So actually this is 4. This one you can find lah. Okay, so now with that, can you find what is tangent 180 minus P? This is 180 minus P. What is tangent 180 minus P? O over A. What is O? What is A? Just like that only. It's the same thing, just that now they will use obtuse angle to confuse you a bit. Okay, but the ratio is the same. It's still O over A because we are talking about this acute angle. Okay, next one. What about cosine P? So remember, this P that we are talking about is the obtuse one outside. The obtuse one. So how is this related to the acute answer? Just now we say, right? How is this the same as the acute answer? From the first page, just now we had this. Just add a negative sign in front. So cosine P is negative cosine 180 minus the P. Because this is acute. And this is the obtuse one. So just now we established that the obtuse one is negative of the acute. So how to find cosine ratio? What is cosine? A over H. So A is 4, 5. So just with the negative sign. So it's the same way as how you find originally, but just add a negative sign. Okay, same thing, tangent P. P is obtuse. But I want to relate it to the acute one. So just now on the first page, we know that tangent obtuse is negative tangent acute. So this is the acute one. So same triangle that I'm referring to now. Tangent is O over A. So it's 3 over 4, but with a negative sign. So just remember same ratio, but add in the negative sign will do. Yes. Question you will see for O level. This is an O level question. They ask you to find the theta when sine theta is 0.34. Okay, let's look at question 2 then. They give you a right angle triangle, and then they give you some length, and then they say, can you find sine of x? Okay, sine of x is a ratio. Remember that. So sine of x is O over H. So go and look at the right angle triangle they gave you. It's always the right angle triangle. So this is H, A, O. So my O over H, before I can do that, I need to use Pythagoras theorem to find O first. So to find O, why my pencil suddenly so thick? Okay, so it will be 13 square minus 12 square root. What is that? 5. Oh, 5. So since I know this length is 5, then the sine ratio here will be 5 out of 13. That's all. Don't go and find the angle x. I don't want. I only want to know the ratio. So give me 5 out of 13. So that's A's answer. Okay, part B is a bit different. I want to find cosine of the angle PRS. This is the obtuse angle. So remember when we were at the second quadrant, it is obtuse, you go into the second quadrant, you still look at the acute triangle beside it. Okay, you still look at the acute triangle beside it, just that the ratio might differ a bit. So if we look at the triangle next door, so this one, although it's this angle we are talking about, actually we are looking at this right angle triangle. Okay, so take note, I want to find this is the same as finding negative of the cosine angle beside it. This is the key. Can you see? My cosine 150 is negative of my cosine 30. It is just negative of the ratio. Because they won't reflect the negative here, you have to add it in on yourself. Imagine that that thing is on the second quadrant. So the only difference is this one was cosine 30, but when I try to find cosine 150, okay, it is negative of my cosine 30. So same thing, when I'm finding cosine of PRS, it is negative of the cosine of PRQ, the one next door, but you add a negative sign. Okay, so to find the answer, it's just A over H, so it's 12 over 13 with the negative sign in front. So that's the only tweak that you need to be comfortable with. Yes. Okay, see, PRS is this obtuse angle. So I'm interested in finding the angle beside it, which is the acute one. So same thing, when I was 150, I go into my second quadrant. But I cannot find the ratio using a non-right angle triangle. I have to look at the ratio beside it. So the relationship for cosine 150 when I'm looking at the triangle form, it is negative root 3 over 2, which is negative of cosine 30. Can you see? This one is negative of my cosine 30. So the relationship between cosine 150 is equal to negative cosine 30. Just add the negative sign in. You will get the same value. Essentially, they are all root 3 over 2. But just that if you go into the second quadrant, there is a negative sign in front of it, that's all. Because in that quadrant, my A value has changed to a negative one. Yeah, so the ratio changed. Just that when we are drawing here, we cannot reflect the negative. Yes.
How do you get opposite this by
Pythagoras theorem. Yeah, Pythagoras theorem. Okay? Okay, next one. 90 minus x is this angle here. So it's an acute. No need to look at any other quadrant. So this is my acute angle. So remember, you label your how. So this is hypotenuse, adjacent, opposite. When your angle changes, your how changes. So what is the tangent ratio now? What is the tangent ratio? What is tangent 90 minus x? What is O over A? No, look at the blue one.
Oh yeah.
12 over 5. So the only difference now is I'm no longer looking at x. I'm looking at the blue angle now. So my hypotenuse is still the same, but my adjacent side changed because my angle has changed from here to here. So my O over A is 12 over 5. Okay? Next one. Okay, it will get better. Okay, show that BD is 13. This one no problem, right? It's just Pythagoras theorem by PT. 12 square plus 5 square square root. So that's why you get 13. So this one no problem, shown. Okay, now I want to find the ratio. So tangent BDC, when it's acute, you're happy because you're just referring to this. You don't need to care about sign. So tangent is O over A, so you will get 12 over 5 for the first answer. So this one clear cut. If it's acute, it's always very direct. Okay, next one is BDE. Yes. No need. You can leave it like that. Okay. Then BDE is the angle next door. Oops. Interested in now, the black one. So remember, obtuse we must link to the acute, right? But for sign ratio, it doesn't matter. It will be the same as the sign of the acute beside it. Remember that? So sine 30 and sine 150, they are equal. So no need to add the negative. Yes?
What if you write this sine bracket 180
100?
180 minus
Also can. Also can. Okay, so it's the same answer. So it's just 12 over 13 over h. Okay, 12 over 13. No problem. No need to add negative because in the second quadrant it's the same thing.
So the sine acute angle and sine
Obtuse,
is the same.
same ratio. Okay, last one, ABD. ABD is here. This one. So it's an obtuse angle. You need to relate to the acute beside it. So the blue one, you need to relate to the green one. So like label your H, A and O. So I'm interested in cosine. So remember, cosine of obtuse is negative of the acute. So add in a negative sign. Write down the angle beside it, which is DBC. The green one. And then it will give you A over H. So 12 over 13. But add a negative sign. Okay, so that's the only difference. When it's sine, it doesn't matter. When it's tangent and cosine, it matters. We just label. Okay, if you don't want to label this, you prefer to write it as 180 minus angle ABD also can. Okay, if you prefer to write that. B part 3. Okay, cosine of the blue angle is the obtuse one. So I need to relate to the acute beside it. So cosine of the blue one is negative of the cosine of the green one. So that's why I write this one, this statement here, before you sub in. So it's just like cosine 30 is negative of cosine, cosine 150 is negative of cosine 30. No need, because this one is not on the grid. But actually on the grid we know that this is the behavior. So we use the result to apply to this. Yeah, yes.
Can it also be written as cosine 30?
Can it also be negative cosine 30 is cosine 150, can. Same. Yeah. Okay, next one. If they don't draw the triangle for you, you can draw your own, no problem. Okay, depending on what they want. So they want BPC. Okay, so this is the triangle, sorry. BPC. So the angle is this one. The angle that they are identifying is this one. So tangent means H, A, and O. So tangent is O over A. You go and read the coordinate here. So this one is minus 14. This one is 10. So it tells me that O is 24 units from negative 14 to 10. And then your A from 4 to 14. So that's a 10 units. Okay, H I can't read. I have to use Pythagoras theorem to help me. So 24 square plus 10 square. Then I take a square root. It gives me a nice 26. So my H is 26 units. So I can find the three sides by reading the values on the grid. So now tangent BPC is O over A. So it's just 24 over 10. Okay, simplify it always.
What's the little arrow?
What error?
Arrow.
Oh no, I'm just saying that
The CPA, BPC.
it's equivalent. I can write this as this instead also can. Oh, what is this cap called? It is the same as angle BPC. And angle BPC, also correct. So it's just a different way of representing, yes. Even if they don't write, it will be in a fraction form. But if you give me decimal, I will accept. Yeah. So instead of 12 over 5, you give me 2.4. If they never say write as a fraction, I will also accept. Okay, because question never say must leave as fraction. Then decimal is accepted. Okay, next one, tangent CPA. CPA is here. Is the obtuse. So what is the acute beside it?
Like a marking on
Marking on top. This one is the angle. It's a symbol for angle. Yeah. Okay, what is CPA, tangent CPA? No need, because I'm not finding the angle. I'm finding the ratio. So what is tangent CPA? I want tangent of the red one, the obtuse. So I should look at the acute, but add a negative sign. I already found from part A that the acute is 12 over 5. So I just add a negative sign only. Don't even need any working. Just put a negative sign to my first answer. Okay, because traditionally the red one is negative of the black one. Ashriel, Marius, and Rishan. Very heated discussion. Where Ashriel you show? Only got one screen and tell me your homework is there. Okay, last one, area of APC. So this one, don't need to think so much. If I'm interested in finding the area of this slice, the yellow triangle. Just give me the half times base times height will do. Don't need to think so much. This is the base. From 14 to 22 is 8 units. Right? And then the perpendicular height is here. 24 units. So you just give me your half times base times height. When it's on the grid, it's always very easy. So it's 96 units square. Okay? So this is part C. Yes. APC not right angle. So I rely on the acute beside it, the right angle triangle here. So this is the acute angle, right? This is the obtuse angle. I will refer to the acute beside it. So tangent of this is negative tangent of this. So I look at the triangle below, the blue one, to help me find the ratio. Area, just use half times base times perpendicular height. You tilt the shape. Yes. Isn't it what? 26. No, it's from 14 to 22. I only want the yellow triangle area. So the base is from 14 to 22, which is 8 units only. Then the perpendicular height is here. Yeah. So you all must see the triangle in this way. If I take this out and then I turn it, it's not right angle, but you use base times perpendicular height. So can you see there is this base times the perpendicular height? Yes. So it's like as if it's like that. So base times perpendicular height times half. Okay? Can So that's question 4. Let's look at the next one. Because obtuse for tangent is negative. Yeah, so you just add in the negative sign.
Just find the ratio, then you see the
For the acute, then yes, correct.
How do you figure out
How do you figure out?
the quadrant?
No, when it's obtuse, it's in the second quadrant. Because it's more than 90 degree, ma. Yeah. Okay, next one. This one. Quick one. I have a ladder leaning against the wall. Given that sine of x is 5 over 13. Okay, take note. Sine of the obtuse is the same as sine of the acute. This one is equivalent. So it's like as if they tell me that the sine of 180 minus x is also 5 over 13. So I go to my right angle triangle and I label my H, my A, my O. They tell me that O is 5 units and H is 13 units because this is O over H. So with that ratio, I can find my A. So 13 square minus 5 square, square root, 12. So this part here is 12. So I know all 3 sides already. Now question say, can you find tangent ABC? That means this one. So no problem, right? I already have my 3 ratios. So what is tangent ABC? 5 over 12. No negative, no nothing because it's acute. It's always positive. Okay, next is DCB. This one next door. This is obtuse. When you are given an obtuse, look for the acute next to it. And then label your how. So H, A, O. So with the cosine ratio, what is the ratio of DCB? What is cosine DCB? Negative 5 over 13. Because this is A, this is H, but because what I'm truly finding is the obtuse beside it, you need to add a negative sign in front of it. So that is it. You find Tuakaso the same way, but if it's obtuse, add negative for cosine and tangent. Okay, add negative for cosine and tangent.
This is quadrant 1.
Yes, quadrant 1. Okay, sine ADE, quick one. This one is obtuse. Which one do I look at? ADB, this one. I should look at the acute next to it. So the right angle triangle, I focus on is this yellow one. So I want sine, right? Sine is H, A, and O. So what is this answer?
7/25.
Yes, that's all. Done. Okay, next angle I'm interested in is ACD. This one is obtuse. So which angle should I look at? The one next to it, which is acute, this one. So I'm going to focus on the blue triangle now. So label your H, A, and O based on the blue. So H, A, and O. Tangent is O over A. So I need to have A first. How to find A? This one. I use Pythagoras theorem. So I'm going to use A. I don't have enough info. Oh, I can use the big yellow triangle. 25 square minus 7 square square root. Is it a nice answer? Oh, it's 24. So very good. This is 12, 12. Okay. So knowing that, I can find tangent already. What is it?
7/12.
Okay, but take note, because I was originally finding the red one, I need to add in a negative sign. So remember, whichever obtuse, find the acute beside it. If it's obtuse, add a negative sign for tangent and cosine. Okay, so it's quite standard. Okay, next one. BAC. This angle. So H, A, O. So acute, no problem. What is the sine ratio? What is the sine ratio?
6.
Oh, this one is 10 for your info.
6 over
6 over 10. So give me 3, 5. Okay, what is cosine ACD? The one next door. So I look at the acute beside it. So H, A, O. What is the cosine? Negative 6 over 10. So negative 3 over 5. Area of ACD, half times base times height. The base is 10. The perpendicular height is 8. So half times 10 times 8. So 40 units square.
Wait, you said these kinds of questions, right?
This is the standard question for Pythagoras. For trigo ratio. Okay, the only one that it was horrendous is this one. You all forgot how to use converse of Pythagoras theorem. So I just write it one time here. Converse of Pythagoras theorem, you look at the triangle they want you to prove. Always start from the longest length. Ravan listening or not? So start from the longest length. AC square is 13 square, which is 169. Okay, then go and sum up the squares of the other two sides. So you have to write this, an square plus nc square is 12 square plus 5 square. You are supposed to prove. So you cannot tell me straight away 12 square plus 5 square equals to 13 square. That's not proving, you're just stating it. Okay, so 12 square plus 5 square is 169, which you realize is equal to AC square. So if you can establish this equivalence, then you can quote by converse of Pythagoras theorem. By the opposite direction of Pythagoras theorem. Okay, since you have proven that the sum of squares of the other two sides is equal to the square of hypotenuse, therefore angle A and B is 90 degrees. Okay, so this is the standard proof. It's 2 marks in O levels if they ask you. So prove it the right way. Yes. Can.
The figure is throwing it off.
Okay, once you prove the right angle triangle, quickly go and write down. Then you can use your Tuakaso already. Okay, so a quick one. ABN is this acute? Look at the big triangle, the blue, the gray one. So HAO. So what is tangent ABN? What is tangent ABN? The gray triangle, what is O over A? 12 over what?
12 over 11.
Not 11, 16.
Yeah, 16.
So you give me 3/4.
4, 3.
Yeah, 3/4. Okay, as a fraction. ACB, this is obtuse. So look at the one beside it. This one. So this is H, A, and O. So what is the cosine of ACB? What is cosine ratio here? 5 over 13. But at a what? Negative.